Hello and welcome to a new video for the Zeta Math UC workbook, which my class is called Middle School Math. We're going through this workbook. It's a great time. We're on lesson 13, which is talking about reading percents in a pie graph. Super applicable to real life because this is a way to represent data. So we might see pie graphs whenever we're looking at studies showing us information. We might look at them whenever we're on social media, either for real pie graphs showing information or memes that are just trying to be funny. So whichever thing motivates you to learn how to read pie graphs, whether it be memes or real life stuff, then, here's where we are. So a pie graph looks like a circle that is divided up into slices, kind of like what you would do with a pie, unless you're one of those weird people that just digs in with a fork in the middle or on the side. I don't know what's wrong with you if you do that, but so we divide it into slices. Now, sometimes we divide those slices evenly, but other times it doesn't make sense. We just base it off of what our data is. So on the screen here is a pie graph that you can see that, okay, this pie graph is divided up into 4 sections. So before now, we might have said, oh, we can talk about how each of these slices is a fourth, right? We can think about just fractions in general. Each of these slices is a fourth of the pie. But now we have 2 other ways, right, that we can represent a fourth. We can represent it as a decimal, which we might have this memorized, or we might be working on memorizing this, that 1/4 as a fraction is the same as 0.25. Thinking about quarters helps, right? A fourth is a quarter, which is like a quarter as far as money goes. And so we can think of each of these slices as 0.25. But also we can, I'm putting this in the wrong place. But also we can think of it as the percent, and that's what we're gonna see on our pie charts today is percents in our pie graph. So each of these would be 25%. Remember that percents are out of 100. So since we're talking about our pie chart is totaling up to 100%, basically, this is not a situation where we're going to end up with more than 100% like we had in the last lesson. These 4 slices have to add up to be 100, which since they're evenly sliced, that's why this is going to be 25% for each. Now these can be divided up in lots of different ways with lots of different percents going on. And what we're going to do is think about how do I look at what the pie chart is telling me and then answer information about it. So let's look at example 1. Here's our pie chart, favorite colors. And I actually asked my current class to answer a survey. I got 10 responses, which really made the percents on this work out nicely. So thanks to the 9 of you plus myself who answered. Favorite colors out of the choices I gave, which were purple, blue, orange, red, green, and yellow. So 50% answered blue. That's what it means that there's a 50% on blue. Also underneath you can see that there are labels that show us which is which. Now I purposely made this so that purple is the color purple, but that wouldn't necessarily have to be the case. If we weren't talking about colors, we'd have to pay attention to, okay, what color represents each thing. So purple is 20% of the class that answered. That's their favorite color. Blue is 50%. Orange is 10%, red is 20%. Green and yellow aren't on here because they didn't get any votes. Poor green and yellow. So they're both at 0%. So there's a number of things that we can kind of think about as we're looking at this. So just from the pie graph itself, we actually are not given information about how many people were asked this question. So I know how many people were asked this question, but it's not apparent just from what the chart says. So what we can do right now is just think on number 1, what color is the favorite of 1/10 of the class? So we'd look at our pie graph and say, well, which one of these percents is equal to 1/10, right? So 1/10, which is also saying 0.1, right? That's also 1/10, which is also saying 10%. Think about, we're talking about 1/10 of 100%, which is 10. So we're looking for which of these colors is 10%, which is orange. Now, I just kind of picked one of them to kind of pick out. We could have been asked, what is the, what did we answer with most as our favorite? That's not the best way to phrase that question. What am I trying to think of? What did the majority of people pick, for instance? Or what was the biggest response or something like that. That would be blue because blue is 50%. I guess majority of people isn't quite true. Majority means typically over 50%. So since it's at 50%, that's not actually a majority, but it's close. But those are some things that we could be asked about. We could be asked, which two colors were picked evenly, like had the same amount picked. So we'd say, okay, well, there's two that are 20%. Actually, there's two different answers for that, right? We could say red and purple were both picked the same amount, but also green and yellow were both picked the same amount because they weren't picked at all. So those are some questions that we could be asked that we just have to kind of look at this and sometimes think about it as fractions or decimals, if that would help. But just think about, what is this data actually showing? Then the other thing we can do is we don't know how many people answered, except that I told you earlier how many people answered, but let's pretend we didn't. They can tell us how many people answered and then expect us to figure out, what does that mean for each category or a specific category. So for 2, it says if 10 people answered the survey, how many people chose each color? Well, let's think about that. If we've got 10 people and 50% of them picked blue, how many people picked blue? Can you figure out 50% of 10? Well, 50% is the same as thinking about half, right? So half of the people picked blue, half of 10 is 5. We can kind of go from there. Something like 50% is the easiest, right? Because that's a half. We can think about if we've been working on memorizing it, 20% is like a fifth, right? So we can say, well, purple and red both were a fifth of what we had. So let's see, a fifth of 10. We might come over here and actually multiply that out. Or it might be that this is something you can kind of visualize in your head. That if I'm going to put 5 people here, that means I have 5 people left to go in these other 3 categories. Well, that means it only makes sense to put 1 person here, 2 people here, 2 people here. I didn't want to draw full on people, so that's their heads. They're representing themselves. So it must be that 2 people answered purple and 2 people answered red. And then for 10%, those are supposed to be heads, not zeros, by the way. So for our 10% for orange, that leaves us with just 1 person who picked orange. And then green and yellow both were 0 because they're on our little, we call this a key down here, or we might call them labels. So our key down there tells us that, oh, green and yellow were options. They just don't show up on our pie chart. So so we can include them and say that 0 people picked them. We could have though said, hey, this data, what if it was 100 people and figured out how much would be in each category? Because one of the things we do with data is we might take a smaller set of information, like survey 100 people, and then we might say, what does that make us think would be true if instead we talked to 1,000 people? And there's that's statistics, and there's all sorts of things about statistics that are important to know before you just start making kind of assumptions. But that's one of the things we could do is we could say, hey, looking at this pie chart where half of the class had blue as a favorite color, maybe if I had to guess on somebody's favorite color, I might want to pick blue because it seems like a lot of people like blue. It helps us kind of make informed decisions, which is cool. Let's look at example 2. On example 2, this says we've got dogs or cats as a preference. So I asked the class, do you prefer dogs, cats, both, or neither? So it's a little bit trickier whenever it's kind of a grayscale like this, but our Math UC workbook is in black and white. So I thought it would probably be helpful for us to get a feel for what that looks like, even if it's more fun whenever it's in color. So one of the big questions that we're likely to be asked is either, what does most of the class, what did most people respond with, or what did the least number of people respond with? So in this case on 1, it says, what does most of the class prefer? So we'd look for the biggest slice of the pie, which is 80%, and we'd relate that to our key down at the bottom is the lightest shading, which goes with dogs. So we'd say dogs. Most of the class preferred dogs. Now, if it said, out of these 2 options, what did most people prefer, then we'd limit ourselves to only looking at those 2 categories and seeing which one was bigger. But if it just says overall, then we're looking for the absolute biggest. Let's see, this time it says if 200 people answered the survey, how many people prefer cats? Well, let's see, cats is this slice right here, just comparing the shades of gray we've got. So this says 10% of people like cats from this survey. So if there were 200 people, we need to basically say what's 10% of 200. Anytime we use the word of in math, that means multiply. So 10% of 200 means do 10% times 200. But remember from our last two lessons about percents that we can't multiply with this percent as a percent. We have to change it to a decimal or fraction first. So it might depend on you what your preference would be. Do you prefer to rewrite this as a decimal, which would be 0.1, and then multiply? Or would you prefer to write it as a fraction, which would be 1/10? I actually kind of like doing the fractions together because there's a cool trick where you can cancel a 0 out of each of these, and then on top we would have 1 times 20, which is 20, and on bottom we'd have 1 times 1, which is 1, which means this is 20. If we do it with the decimals, we'd probably come over here and actually rewrite it like this, and then multiply it out. We get 0, 0, 2, and then we know we need 1 decimal place. So see, that's two different ways of getting the same answer. You don't have to do it both ways. I just wanted to show you both because you've actually been doing fractions longer than decimals, so you might feel more comfortable with fractions if you feel like you're good at them. Or since we've done decimals more recently, maybe that's the thing that makes more sense to you. But our answer to this is 20. That if 200 people answered the survey, which they didn't, then 20 are what preferred cats. I picked 200 because it was a number I knew would work out nicely for our math. I could have picked anything. Only 10 people actually answered the survey. So, you know, whatever. The other side of this that we're going to do with this lesson is make our own pie graphs based on some information we're given. So this says use the given information to shade or, that's supposed to be an or, shade or color the charts. My bad. Make a key to match. So it also specifies for us, it tells us how much each part of the pie is worth, which is nice. Although you could probably count the slices and figure that out as well. So this says each section of the chart is 25%. In other words, it's divided into quarters, right? So if we wanted to shade this, we'd say, okay, what do we got? We're talking about free time. 25% of free time is doing chores. So I'm going to pick orange for chores. Ooh, that's going to be a little too large. I'm going to pick orange for chores, and I'm going to pick a fourth of this to shade. And so you could use different colored markers or pencils. You could use just different, like, you could, if you just have a pencil, you could try just doing like different, you know, intensities of pencil. You also could make patterns to show the difference between them, which I'll, like an example of that would be for 25% of free time reading a book, I could choose to make polka dots. And then, I mean, this is going to be really good polka dotting, right? But as long as none of the other ones that I do look like this, and as long as I fill out my key with this pattern, then someone would be able to look at it and go, oh, okay, I see what you mean. Typically, that's not what we do with actual pie graphs, but this is a situation where you may or may not actually have colored pencils or markers handy. So that's fair. You probably do, but you might not. 50% of free time playing video games. So I'm going to shade it green. And so 50% is half. So it gets 2 of these quarters, right? So if you aren't already relating percents to fractions, that would be something that would be really, really helpful to start trying to do. That when we think of 25%, we should think about quarters or 0.25. When we think about 50%, we should be thinking about half or 0.5. There were, in the last 2 lessons, there were some sections on, hey, these are fractions that it would be nice if you had memorized the decimal and percent equivalent. So this is just another place where that would be helpful. We want to make sure to make it a key, so that's kind of what I did here to this side. I think in our workbook it actually has little boxes for you to color in, which is really nice. So you have to tell people like which one goes with which, so they know kind of what's going on with your data here. All right, last one here for us. We're gonna do some shading. Again, that's an or instead of an of right here. So this is time spent on homework. So 30% of school on science, math, and technology. This is, we actually in class came up together with what we wanted this last pie chart to be. So we decided kind of time spent on different parts of our schoolwork. We actually came up with like 10 different subjects that then we divided into different categories. Each of these sections is 10%. So 30% means I would need 3 out of those, right? And then we'd look at the next one, 30% on grammar, reading, and languages. So I could do blue, and 30% would also be 3 of these slices, which is close to a third, but not quite. In case you are wondering, which you're probably not, a third actually doesn't, 3 doesn't divide into 100 evenly. So a third ends up being 33.33333333333333333 forever and ever and ever percent. So that's why we've been sticking with like things that are not repeating decimals because we're just not quite there yet. So that's coming up though. Get excited. 20% of school on history and geography. So that would be 2 of these slices. So this slice and this slice. Now, if you are, watching this and doing your homework and you're like, man, pie really sounds good. This is one of those times where you could be like, hey, parent, it would be really, really helpful to me doing my math homework and understanding it if we ate pie. Totally, totally reasonable in my opinion. 20% of school on like kind of our extras, gym, theater, band, choir, anything that would fall into that category. So that would end up being, so basically what's happening is that this is 2/10 because these are divided into 2, or, that's the same as it being 1/5. But because each of these slices were 10%, you're actually able to go through and say, okay, how much is 20% if each slice is 10%? There should be 2 of them, right? 10 plus 10 is 20. So this is how we would color it. I've got kind of a rough key out to the side here. The other thing that pie charts need typically are titles. So we might title this how we spend our time on schoolwork or things like that. But that's the idea. I think pie graphs are pretty interesting and hopefully they're not super tricky. The tricky part is that now we're trying to do percents with the idea of something else. So that might be where you get hung up. So just remember, you can always change a percent to a decimal or a fraction and see if that's something that helps you visualize better, especially fractions, I think, make it easier to visualize. Thanks so much for watching. Hope that you enjoyed it. Leave me a thumbs up if you did, and I'll see you in the next video.